This is a question under the topic of linear graphs. So the prerequisites for this video is I'm going to assume that you understand what a gradient is, what a y-intercept is, and how to find those. Okay. So for this question, you're asked to find the equation of a straight line passing through each of the following pairs of points. So a straight line passing through EF and IJ. Okay. But okay, before we get into that, let's quickly recap what the equation of a straight line is. Okay. Generally, the equations of straight lines will take this form: y equals to mx plus c. Right? M is a constant, c is a constant. M represents a gradient, the gradient of the line, which tells you how steep the line is, and c represents the y-intercept. Okay. So for example, if let's say you know the gradient of the line is 3, it will be 3x, and you know that the y-intercept is 4. This will be the equation of the line. Okay, y equals to 3x plus 4. Let's look at a few easy examples. All right. Let's say you are given this kind of graphs, right? And then you're asked to find the equation of the line. Okay. For the first graph, right, you're told the gradient is 4, so straight away you can write y equals to 4x, right? And then c, y equals to 4x plus c, c represents the y-intercept, right? The y-intercept is this point here, where the graph cuts across the y-axis. Okay, that's known as the y-intercept. So if it cuts at 3, straight away you can write the equation as 3. Y equals to 4x plus 3. For the second graph, we know that the gradient is 5 and the y-intercept is, okay, this should be negative 2, right? So the equation will just be y equals to 5x minus 2. And for the last one, you see it's a downward sloping line. The gradient is negative 1. Okay, so it'll be y equals to negative x because it's negative 1 times x, right? And the y-intercept is 6, so this will be the equation of the line. Okay, so get used to quickly seeing how to generate the equation of the line given this kind of information. All right. Okay, next, you might see this kind of graphs, right? This will be a little more complicated because you're not given the gradient, right? But you are given 2 points on the line on the graph, right? So you can actually calculate the gradient yourself. Remember, a gradient is rise over run, right? Rise over run, and the rise is the vertical distance, and the run is the horizontal distance, right? Just think of like rising up and then like running horizontally. Okay, and if you forgot the formula of the line, I mean the formula for gradient is y2 minus y1 over x2 minus x1. Because y2 minus y1 gives you the vertical distance, right? The vertical change in a line. x2 minus x1 gives you the horizontal change in a line. So since you are given these 2 points, right, you can see that going from, let's say, point A to point B, right, the vertical distance is just 4 units, right? Because at A, the y coordinate is 0, at B, it's 4, right? So yeah, the rise is just 4 units. The run will be 3 units. When you go from negative 3 to 0, that's 3 units. Okay, so the gradient is 4 over 3. And we are given the y-intercept, which is 4, right? So you can form the equation of the line straight away. Y equals to 4 over 3x plus 4, right? This is the y-intercept. Okay, the next one, same thing. You can calculate the gradient yourself. The rise will be 7 minus negative 2, right, which is 9 units. Okay, just from negative 2 up to 0, that's 2 units, right? From 2 units to, I mean from 0 units to 7 units, that's another 7. Okay, so altogether that's 9 units. Then the horizontal distance will just be from 0 to 3, that's 3 units. So the gradient is 9 over 3, which is 3. So the equation of the line will be y equals to 3x. And what's the y-intercept? The y-intercept is negative 2. Okay. For the last one, it's a downward sloping line. So straight away you should know that the gradient will be negative, right? Same thing, you have to calculate the rise, right? Since we are looking at the points from left to right, okay, it's when you go from point A to point B, you're going downwards, right? If you look from point B to point A, you're going upwards, but since we always look at it from left to right, it's downwards. So the rise will be a negative number. In this case, it's negative 8. Okay, and then the run is 2 units. So the gradient is negative 8 over 2, which is negative 4. So the equation of the line will be y equals to negative 4x. And what's the y-intercept? The y-intercept is 8. Alright? For the last type of graphs, okay, we are not given the y-intercept. Okay, so this will be slightly more challenging, right? Again, we can find the gradient of the line because we are given 2 coordinates. Okay, the rise will be from 2 to 8, that's 6 units, right? And then the run will be from 1 to 3, that's 2 units. So the gradient is given by 6 over 2, which is 3. Right, so you can write y equals to 3x plus c. We need to figure out what c is. C represents the y-intercept here. Right now we don't have it, right? But no issue. Why? Because we can use any of these points that lie on the equation. Remember, the equation of a line is kind of like the instruction set for you to plot the line, right? If you're given the x coordinate of a point, the equation will tell you what the y coordinate should be, as long as the point lies on the graph. Okay, so let's use point A for example. Okay, we know that the x coordinate is 1, right? So we can sub x as 1, right? And since A lies on the line, then the equation should tell us that the y coordinate will be 2, right? That's what the equation does. Given x, it will tell you what y is. So working backwards, right, you can solve for c. Okay, so c will be 2 minus 3, which is negative 1, right? So the equation of the line will be y equals to 3x minus 1. Okay, you can do the same for the next graph, right? Again, let's find the gradient first. The rise will be from negative 2 to 8, so that's 10 units. Okay, the run will be from negative 1 to 4, that's 5 units, right? You take 4 minus negative 1, right? Okay, so the gradient will be 10 over 5, which is 2. So we can write y equals to 2x plus c. Again, we can use any coordinates. We can use a or we can use b, right? Let's use b. Given that x is 4, y should be 8, since it lies on the line, right? Let's work backwards to find c. Okay, so c will be 8 minus 8, which is 0. So our equation of the line will be y equals to 2x plus 0. So it's just y equals to 2x. Okay, so this graph doesn't really make sense. By right, I mean, since the y-intercept is 0, this line should cut through the origin, because that's where the y-intercept is. Okay, yeah, let's move this down here. It should cut through the origin like that. Okay, for the last graph, right, we can use a different way to find the equation of the line. I mean, we can use the same way that we used for the first two graphs, but some of y'all might be more comfortable with this way. Okay, the rise, again, we can find the difference between the y coordinates. So 6 minus negative 12, that's negative 18, right? From point A to point B, you move downwards by 18 units. Okay, then the run will be from negative 1 to 3, that's 4 units. Okay, so the gradient is negative 18 over 4. If you simplify that, it's just negative 9 over 2, right? So some of you might have seen this type of equations. Y minus y1 equals to mx minus x1, right? From here, use any of the coordinates to sub as x1 and y1, right? So let's use point A. So y minus 6 will be equal to, the m is still the gradient, right? So negative 9 over 2, x minus negative 1. Okay, remember we are using point A, so we must use the x coordinate and the y coordinate of point A. Then from here, we just expand and make y the subject. Okay, y minus 6 equals to negative 2x, 9 over 2x. This will become plus 1, right? So minus 2. Okay, because negative 9 over 2 times positive 1 will just be negative 9 over 2. And then we add 6 on both sides. So y equals to negative 9 over 2x minus 9 over 2 plus 6, which will be negative 9 over 2x plus 3 over 2. Okay, so the intuition behind this is, remember, m represents the gradient, right? The gradient tells you how steep a line is. Okay, in other words, for every unit of horizontal distance, how much vertical distance does your line increase by? So let's say it's 3 units. So you can say that your line increases vertically by 3 units for every 1 unit of horizontal distance. So you see how that captures the idea of the steepness of a line, right? So if you look at this, right, y minus y1, you are capturing the vertical distance, right? Y minus y1 is the vertical distance. Vertical change. This will be the multiple. This will be a multiple of your horizontal change, which is x minus x1, right? Horizontal change. And that multiple is captured by the gradient, negative 9 over 2, right? Sorry, let's use m. Okay, so if we look at this example, right, the gradient is 3, right? You can see that for the vertical change in this line is always 3 times the horizontal change of this line. So that's why we can use this equation, and then from here you expand, make y the subject, and then it'll give you the equation of the line as well. So this is another way to find the equation of a line given 2 points. Okay, so moving back to the original question, right? Okay, I'm just going to use one example, right? E and F. Okay, to help you visualize, right, you can actually just plot the points out. Okay, E is 2, 4, so that's somewhere here, right? 2, 4, and F is negative 2 and 3, so somewhere here. F is negative 2, 3. So to find the equation of the straight line going through it, right, let's draw the straight line. Remember, we just have to find the gradient. So the rise is 4 minus 3, which is 1 unit, and the run is negative 2 to 2, that's 4 units. So the gradient is 1 over 4, right? So I'll use both methods to solve this. So okay, the first method, y equals to 1 quarter x plus c, right? And then just sub in any point. You can sub in f, you can sub in e, right? Let's use f, and then work backwards to find c. So when x is negative 2, we know that y will be 3, okay? So 3 equals to negative half, plus c. C must be 3 plus half, right? So 3.5. Okay, so the equation of our line will be y equals to 1 quarter x plus 3.5. Method 2, y minus y1 equals to mx minus x1. Just sub in the any point, right? Let's use 2 and 4. Okay, y minus 4 equals to the gradient which we found is 1 quarter times x minus 2. Then we just expand. Y minus 4 equals to 1 quarter x minus half. Y equals to 1 quarter x minus half plus 4, which is 1 quarter x plus 3.5. Okay, yeah, better to leave both in fractions. So y equals to 1 quarter x plus 7 over 2. Or, yeah, you see, you arrive at the same answer using both methods. Just pick one method and stick to it, be familiar with it.